Hey there, it's Miss Adams from Flamingo Math. We're starting chapter 2 today. We're going to talk about arithmetic and geometric sequences. In today's lesson, we're just going to consider what an arithmetic sequence is. Let's look at the definition of a sequence for a minute. Here I've got a list of numbers, 2, 5, 8, 11, 14. We call this a finite sequence because the domain is only 5 terms. 2 is our a sub 1 term. 5 is our a sub 2 term. 8 is the a sub 3 term. 11 is the 4th term, or a sub 4, and 14 is a sub 5. If we consider that this sequence continues on indefinitely, then out here at the end somewhere, that is our a sub n term. But just listing the 5 terms in the sequence, that would be what is known as a finite sequence. And if we have the 3 dots, that's called the ellipsis, and it continues on forever, that would be an infinite sequence. Each one of the numbers is known as a term. Look at example 1 with me, if you will. In example 1, they gave us what is called an explicit formula, and we're to find the 12th term in that formula or that sequence. So to do that efficiently, we would say a sub 12 is 12 times n. N is the variable that we use for sequences. And then evaluating that, 144 plus 3 lets us know that the 12th term in the sequence is 147. We don't have to calculate each one independently until we get to the 12th term. We can use that explicit formula to calculate just the 12th term in the known sequence. For example 2, you're given the explicit formula for part A, and your job is to write the first 4 terms of the sequence. So just like example 1, our n term tells us which term in the sequence we're finding. So 1, 2, 3, 4 would be our substitutes for the variable n. Working through that arithmetic, you should end up getting the sequence -1, 2, 5, and 8. On part B, if we find the first 4, the -1 is going to affect the power, as every time that we have an even power, that -1 will become a +1, and the terms will be either adding or subtracting based on the sequence that we're raising the power to. So in the first situation, we have 5 minus 1, which is 4. But in the second term, we have 5 plus +1, which is 6. And then the third term is 5 minus 1, back to 4. And the fourth term is 5 plus 1, which is 6. So you can see this sequence is going to oscillate 4, 6, 4, 6, and so on. For example 3, let's say the sequence is given by this explicit formula. A sub n is 4 plus the quantity n minus 1 times 5. You want to find the first 3 terms and then find the 11th term. Can you do that on your own? For part A, we got 4, 9, and 14 for the first, second, and third term. And for the 11th term in part B, we substituted 11 in for the variable n, and then 50 plus 4 gives us 54 for the 11th term in that sequence. On this slide, you can see our formal definition of an arithmetic sequence. Notice that an arithmetic sequence has the same difference between 2 terms. The common difference, we're adding a term to the first term to get to the second term, or the difference between each consecutive terms. There's two formulas that you may or may not have seen before. The explicit formula when n is greater than 1, and then the explicit formula when you want the 0th term. We'll use those formulas in the next few examples. Example 4 is asking us, is the sequence arithmetic, and if so, can you write a general rule? So looking between each term, 1 to 5, 5 to 9, 9 to 13, 13 to 17, it appears in this infinite sequence, we're adding 4 to each previous term to get to the next term in the sequence. That's what's called our common difference. So the difference is 4. If the difference is 4, and you want the 0th term, I'm looking back at this formula up here. We're going to use this formula right here. If we want to find the 0th term, we're going to take the first term and subtract the difference between them. To find that a sub 0 term, we want the first term, which is 1, and the difference, which is 4, so the a sub 0 term is negative 3. That's like finding the term that came right before here. So if 1 is the a sub 1 term, negative 3 is the a sub 0 term. Writing the formula using that a sub n equals the difference times our n plus the a sub 0 term. So our nth sequence, or our arithmetic sequence, is 4 for our difference times n plus our a sub 0 term, which is negative 3. So the arithmetic sequence explicit formula is 4n minus 3. For example 5, we want to find the 46th term of the sequence if we have 2, 5, 8, 11, and 14. So our first task is to find what the common difference is between 2, 5, 8, 11. So 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. Our common difference is 3. The a sub 0 term, we found the a sub 1 term and subtracted the difference. So a sub 1 is 2 minus 3. Our a sub 0 term is negative 1. And our explicit formula, a sub n, is the difference times n plus the a sub 0 term. And our task is to find the 46th term in that sequence. 3 times 46 minus 1 looks like 138 minus 1. So the 46th term in our sequence would be 137. Example 6 is for you to try. Your job is to find the 9th term of the arithmetic sequence, whose first term is 8 and has a common difference of negative 5. Give this a try. Our first term is 8. Our difference is negative 5. The a sub 0 term is 13. Here's our nth term explicit formula, negative 5n plus 13. To find the 9th term, 5 times 9 is negative 45. Add 13, and you should have ended up with negative 32 for your 9th term in that sequence. Example 7, the numbers in the sequences below follow a general pattern. Can you write that general rule? So for number 7, we're looking at a common difference between the terms is 1/4. So our common difference is 1/4. You can write it as a decimal or a fraction. And the a sub 0 term, 1 1/4 minus 1, would be 3/4 using decimals. The a sub n explicit formula would be 0 0.25n plus 3/4, the a sub n term. On 7b, the common difference, -1 minus 4, is our difference. That's -5. And our a sub 0 term would be 5 plus 4, so that would be 9. 9 minus 5 gets us to the first term, 4. The a sub n term will be -5 times n plus 9. And then our last example, we're going to use those explicit formulas. The number of seats in the first 16 rows of an arena form an arithmetic sequence. If there are 20 seats in row 1, 23 seats in row 2, there's going to be 26 seats in row 3, and so forth. The common difference is adding 3. Our job is to find out, when we get out here, how many in the 16th row. The a sub 0 term would be 20 minus 3 for 17. That gives us the explicit formula. A sub n is 3n plus 17, and we want the number of seats in the 16th row. 3 times 16, that's 48. And 48 plus 17 gives us a total of 65 seats in the 16th row. So we could write a sentence about row 16. We'll have 65 seats in that row. Can't spell and talk and write at the same time. We'll have 65 seats. That's the end of arithmetic sequences. The second half of the lesson will go over geometric sequences. See you next time.